Okay, let's dive into this. You've probably heard a million times how weird the quantum world is, right? But what if one of its most basic properties isn't just a number in some crazy equation, but an actual physical shape? That's what we're talking about today, quantum spin. It's this property that honestly defines just about everything.
But here's the thing, and this is the big mystery, right? We can measure it, we build tech with it. But what is it? Like physically. If you could just zoom all the way in on an electron, what does its spin look like? That's the huge question we're going to dig into.
All right, so before we jump into some of the newer, maybe more out there ideas, let's cover what science currently tells us. And it turns out when we look out at the universe, spin isn't just some random thing. Nope, it comes in these really specific kind of distinct flavors.
I mean, you can basically take every fundamental piece of our universe and sort it into one of two buckets. Just two, all based on this one property. It's one of the most fundamental organizing principles we've got, and it neatly separates the stuff that makes stuff from the stuff that moves stuff.
And what's wild is how clean this split is. On one side, you've got your fermions. These are the building blocks, right? The electrons, the quarks, the tangible stuff that makes up you and me. And on the other side, the bosons. These are the force carriers, the messengers, like photons, the particles of light. And here's the kicker. One group has this weird half-integer spin, which, get this, means it has to rotate twice, 720 degrees, to get back to where it started. The other group has a normal integer spin. And that's it. Just these two categories build, well, everything.
Okay, so we've got these categories. That's cool. But just knowing they exist isn't enough. The source material we're diving into today really pushes us to ask a way deeper question. Why? Why these two types and not 3 or 10 or a million? What's the fundamental reason reality split itself this way?
And this is where the thinking takes a really crucial turn. Think about it. A property isn't just a label you slap on something. For a particle to have spin, it has to be made of something. It needs some kind of physical structure that allows that property to even exist in the first place.
So this completely reframes the whole problem, doesn't it? We're not just trying to describe spin with numbers anymore. We're asking, what is the actual physical shape? What's the geometry of a particle, or maybe even of reality itself, that creates this thing we call spin?
And that question, it leads us to a really important point, maybe even a critique of how modern physics works. Look, we are amazing at describing the universe with math, but is the math the whole story? I mean, right now, our best tools for getting a handle on spin are all math, pure math. We've got these unbelievably complex algebras and equations that predict exactly how spin is going to behave. And they work flawlessly. But it's kind of like having a perfect weather forecast. The simulation can tell you to the minute when it's going to rain, but it doesn't tell you what a cloud is actually made of.
So this is the big philosophical jump, right? Are we just describing the effects of spin? Or have we actually found the thing itself? Is that beautiful equation the reality? Or is it just a really, really good map of a territory we've never actually laid eyes on?
And this quote just hits the nail on the head. We see two types of spin, so what do? We create two neat little mathematical boxes to put them in. But what if that's a mistake? What if we're just assuming reality is split in two because our tools are only capable of measuring it that way? What if, deep down, it's all one single connected thing?
Okay, so if we're going to step away from the pure math for a second, what could spin actually look like? Well, this is where our source material proposes something pretty radical, something you can actually picture. The big idea here is let's stop thinking about spin as some abstract property that's just kind of attached to a particle. Instead, what if it's a literal, physical feature, like a twist or a knot, in the very fabric of the universe itself? This is just such a cool image. Seriously, forget the equations for a minute and just try to picture this. A single, continuous, elastic fabric that makes up all of reality. Now, spin isn't something on that fabric, it is the fabric, just twisted into a specific kind of knot, a permanent, geometric shape that literally is the particle. So just to make sure we're all on the same page here, this whole fabric of reality idea is suggesting that everything, particles, forces, you, me, this whole shebang, is just a different kind of ripple or twist in the exact same underlying material. It means the universe isn't a bunch of tiny separate Lego bricks. It's one single, continuous, interconnected thing.
All right, that's a pretty mind-bending idea, for sure. But you might be asking, so what? What's the payoff? Why does it even matter if we think of spin as a shape?
Well, here's the real game changer. A physical model could finally give us the why. Just think about it for a second. If spin is a real geometric knot in this fabric, then maybe there are only two ways to tie that knot that are actually stable. Maybe only two twists are possible without the whole thing just unraveling. Any other shape would just be unstable and fall apart. And suddenly, the math isn't the reality anymore. It's just a perfect description of those physical rules.
So, at the end of the day, this is all about a huge shift in the kind of questions we're asking. We're moving from just describing what we see to trying to understand why we see it. It's the difference between listing a patient's symptoms and actually diagnosing the cause.
And that's the real call to action here. The suggestion is that maybe we need to change where we're looking. Maybe the next massive breakthrough in physics won't come from an even more complicated equation, but from a hunt for the literal physical shape of reality.
And that leaves us with a pretty wild thought to chew on, doesn't it? For centuries, we've been using math to draw a map of the universe. But what if the map isn't the territory? What if the deepest secret of everything isn't hidden away in an equation, but is an actual physical shape just waiting for us to see it? And if that's true, you have to wonder, what else have we been missing?